Hello, we are going to look now at example 13, and it says consider a complex number z is equal to CIS of 20 degrees, and let z equals x plus iy be in the Cartesian form of z. First, it wants us to expand and simplify the expression, our complex number cubed, hence show that 3x squared times y minus y cubed all over x cubed minus 3xy squared is equal to root 3. Good, so that's what we have to show first. Next we're going to show that tangent 40 degrees times the tangent 80 degrees is equal to 3 minus tangent squared of 20 degrees over all over 1 minus 3 times tangent squared of 20 degrees. And then we're going to use parts A and B to show that tangent 20 times tangent 40 times tangent 80 is equal to root 3. So we got a lot of stuff going on here. So the first part, we're going to start off with A, right? A wants us to expand x plus I, y, which is our complex number cubed, right? So that's going to be x cubed, right? Plus, it's going to be x cubed plus 3 x squared, right? And then I times yi, right? So that's the next term. Then the next one is going to be a negative 3x y squared, right? Because if we end up squaring the I, it's going to be negative, but that's y squared. And then the last one is a negative I y cubed, right? Good. And that's what that is, because if you cube this one, squared is negative 1 times another I. So we get a negative I and y cubed this way. Good. Now, we want to be able to use that to show that this guy is equal to this. Well, let's put these in complex parts, right? Real and complex parts. So the real parts are going to be x cubed minus 3x y squared. That's my real part, but my complex part is going to be 3x squared y, x squared y, minus y cubed, right? Y cubed I, right? So that's our complex part. And now, if you notice this guy right here, the top guy is this guy, and this guy right here is the bottom guy, right? Well, that's the tangent, right? The tangent of this guy, right? So, but this is here, this guy here is equal to CIS of 20 degrees, right? But it has to be cubed, right? If it's cubed, it's the CIS of 60 degrees, right? 60 degrees of everything that we have over here, which is x cubed minus 3xy squared plus 3x squared y minus y cubed I. Now, this is 60 degrees, and this over this, so we know that that expression right there is the same as the tangent of our 60-degree angle, and that is equal to this guy over this guy. So it's 3x squared y minus y cubed all over x cubed minus 3xy. And xy squared it should be. And we know that the tangent is 60 degrees is root 3. So we used all this right here to show what they wanted us to show. And that one is the first one, so we were able to show that. Good. And next thing we're going to do is show this. We'll do this in another screen now. So let's go here. So let's see. Now we want to show that tangent of 40 degrees, right? And tangent of 80 degrees, right, is equal to 3 minus tangent squared of 20 degrees all over 1 minus 3 tangent squared of 20 degrees. Well, if we can, we're going to show that this is equal to this, so we're going to start it with this guy. Well, these are angles I can't work with my given information, but I do know stuff about my 20 degrees. So I can change this tangent 40 degrees in terms of 60 and 20 by saying 60 degrees minus 20 degrees gives me 40, and the same thing over here. I can take tangent of 60 degrees plus 40 degrees, 20 degrees, right? Good. And that these are angles I can work with. I know how to compute 60 degrees, and I know I have a representation for it up here. So now I can use my compound tangent identities, and this guy right here would be the tangent of 60 minus the tangent of 20 all over 1 plus the multiple of those two. So 1 plus tangent 60 tangent 20, right? Now here we go, and on this side here it's the compound identity, but it's the other one, so it's the tangent of 60. This time it's going to be plus tangent of 20, but on the bottom it's going to be the subtraction, so 1 minus the tangent of 60 times the tangent of 20 degrees, right? And here we go. And now I know the tangent of 60 is root 3 minus the tangent. Don't know what that is yet, but we want it in that form anyways, over 1 plus root 3 tangent of 20 degrees. Good, so I got that. Let's get a little bit of room here. Now this guy is root 3 plus the tangent of 20 degrees. And then I have 1 minus root 3 tangent of 20 degrees, right? And there we go. And then let's see what happens when I multiply. These are conjugates of each other, right? They're complete conjugates, so it's just this times this minus this times this. So on top I have 3 minus tangent squared of 20 degrees up top. And then on bottom I'm going to have, I got conjugates again, right? It's just going to be 1 minus 3, that times that is just going to be root 3 times root 3 is 3, tangent squared of 20 degrees. And there we go. And that's what I wanted to show, right? I wanted to show that it was equal to 3 minus tangent squared of 20 over 1 minus 3 tangent squared of 20. And that's what I have here. So QED. And that's what I showed. So now that I've shown this in A in the previous page, and this here, now I'm going to calculate this out, right? I'll do this on another page, right? So here we go. So I'm going to use this fact and this fact to help me out with this, right? So what I'm going to do is first I have to notice is what do I have? I'm trying to figure out what tangent of 20 degrees times the tangent of 40 times the tangent of 80, and I want to show that that's equal to root 3, right? Well, I know 40 and 80, that's this guy, right? Good. Now, but I don't know what the tangent of 20 is, but I can get it because I know that the z is equal to the CIS of 20 degrees, and then I know that the I also know that z is equal to x plus iy, right? Well, if this is 20 degrees, what's the tangent of 20 degrees in terms of x and y? Well, that's y over x. So now wherever there's a y over x, I know I can implement that. So and this side right here, this guy right here is just y over x, right? Oh, sorry. It's just y over x, right? Now this guy, right, 40 times 80, this guy right here is what I'm working with. 40 times 80, we've, calculated what that's equal to. So that's 3 minus, what's the tangent of 20 degrees? That's y over x, right? Y over x squared all over 1 minus 3, the tangent of 20, which we also know is y over x, right? Now let's see what this is equal to. A little messy there. Get that out of the way. So this is equal to, I still have y over x, right? Inside of here, I'm going to have y squared over x squared, or I can write this as 3x squared minus y squared all over x squared when I find a common denominator of the guy up top, right? You can check this if you want to check to see what that works out, right? On bottom, I'm going to have, well, this is supposed to be squared. I forgot to square that, right? That's squared, right? I'm going to have, I'll have x squared minus 3y squared all over x squared 2, right? Now the good thing is if I do the reciprocal, those guys are going to cancel out. I'm going to end up with y over x. And what do I have? 3x squared. 3x squared minus y squared. That's a square. And then x squared minus 3y squared. And then I'll distribute this guy through. And then what do I end up with? I'm going to have 3x squared y, right? Minus y cubed, right? That's what I have up top. On the bottom, I have x cubed minus 3xy squared, right? And if you notice, right, this is exactly what that was equal to that we showed in the previous one. 3x squared y minus y cubed all over x cubed minus 3x squared. And so this is equal to root 3. And that's what we wanted to show. And so therefore, we know that all this is all equal to, and so I know that 20 degrees times 40 degrees times tangent of 20 times tangent of 40 times tangent of 40 is equal to root 3, and we showed it. Q, E, D. And there you go. Thanks, guys.